Okay, so today we're going to talk about the law of sines. We have solved triangles using trig, but only right triangles. That's what you did in geometry. Then we've reviewed that. You can use trig to solve non-right triangles or oblique triangles, but you don't do it the exact same way. There's a law of sines and a law of cosines. We're going to talk about part of the law of sines today. The first thing we're going to do is we're going to come up with it. So what we do in this first blank is not what you do every time to solve it, just to show you where it comes from. So in this triangle right here that we have that's not a right triangle, we're going to draw in the height. Height is always perpendicular to the base. And when I draw in the height, I've taken that oblique triangle and split it into two right triangles, and we know how to do trig ratios with right triangles. So the first thing that we'll do is we're going to find the sine of angle A. So using our right triangle trig that we know, the sine of angle A, sine is always opposite over hypotenuse, so that's going to be h over b. Then I'm going to solve for h. So to solve for h, I'll just multiply both sides by b. So I have b times the sine of angle A equals h. Then we're going to set up the ratio for the sine of b. Here's the angle b. So for the sine of b using this right triangle, that's opposite over hypotenuse, so that's going to be h over a. And then we'll solve that for h, so that'll be a times the sine of b equals h. Everybody understand where everything came from? And notice that when you label a triangle ABC and then you also label the sides, there's a method to that. You don't get to just randomly place them. The side A is across from angle A, side C is across from angle C, and so forth. Okay, the lowercase represents the side length, the capital represents the angle. All right, so now that I have both of these things equal to h, I can do some substitution. Since a times the sine of b equals h, I can take this and I'm going to substitute it in right there where there's an h. So when I do that, that's going to give me b times the sine of a equals, instead of h, will equal a times the sine of b. So now I'm going to rearrange this just a little bit. I'm going to divide both sides by the little b, so that'll leave me with sine of a equals a times the sine of angle b over side b. Then I'm going to divide both sides by little a, so that gives me the sine of angle A over little a equals the sine of angle B over little b. Okay? So that is part of the law of sines. The law of sines is just a ratio. Okay? The sine of A over A equals the sine of B over B. And then if we were to turn the triangle and draw the height then maybe from B here, and then we could do it for A and C, you'll end up that they're all equal to each other. So we're going to put C in there with it. Obviously, when you get to actually solving these, the angles usually aren't labeled A, B, and C. So it's just the sine of the angle over the side length that's across from it, the sine of the angle over the side length that's across from it. So your actual law of sines looks like this. The sine of A over A equals the sine of B over B equals the sine of C over C. But you only use two at a time. They just all work that way, okay? Are all of your devices in that box? I didn't think so. I should put it in there before I just take it from you. All right, any questions at this point? We good? All right, so this says the law of sines can be used to find the side and angle measures given two angles in any side. So either angle, angle, side, or angle, side, angle, or two side lengths and an angle outside them, side, side angle. Those should sound familiar from geometry, from when you were proving that triangles were congruent. These two were ways that you could prove triangles congruent. This one was not, because it's the ambiguous case and there's no AS in geometry. All right, so we're going to talk about this one tomorrow, but today what we're going to be able to apply this to is angle, angle, side, and angle, side, angle. So we're not, whereas when you were trying to prove triangles congruent, you were comparing two triangles to each other. We just have one here. It's just referring to the arrangement of the information that's given to you. And so both times it's two angles and a side. It just depends on where the side is. So let's look at these two. Because one of the things you're going to want to do when you want to decide, are you using the law of sines or cosines? Today, clearly you're not using the law of cosines because you don't even know what that is yet. And when you're doing the law of sines, is it going to be just the answer or is it going to be the ambiguous case? Well, we're not going to talk about that until tomorrow. So you really only have one thing to apply, but you still need to know how to look at these triangles. So here I have two angles and a side. But you notice how this side is not in between the two angles? That's what makes it angle, angle, side. Here I have two angles and a side, and the side is in between the two angles. That's what makes this one angle, side, angle. So if you get either one of those, it's just a straight up law of sines. Okay, and my law of sines here says, I'm going to take the sine of an angle. So I'm looking for x. The angle across from x is 104. So I'm going to take the sine of the angle, the sine of 104. That's going to be over the side length, which I'm looking for, which is x. That's equal to, well, another angle that I have is 47. It's across from 15. So that'll be equal to the sine of 47 over 15. Okay, then from there, it should be a piece of cake to solve. I'm going to cross multiply x times the sine of 47 equals 15 times the sine of 104. Then to get x by itself, I'll just divide by the sine of 47. So x is equal to 15 times the sine of 104 over the sine of 47. Then that's when you go to the calculator. I highly suggest you use the fraction button. It'll make things a lot easier for you. And type that in. And what do you round to unless you are told otherwise? How many decimal places? 3. So what did we get? 19.901. Very good. And we have units here, so we need to use them. That is centimeter, and that is our answer. What questions do you have? Pretty easy. All right, let's look at number 2. It's angle, side, angle, so it's going to be the law of sines. So I'm looking for x. 42 is across from x. So I'm going to have the sine of 42 over x equals, well, I have a 28 feet, but I don't know the angle that's across from it, and I would need to know that. Can I figure out that angle? Yes, because I have this angle and I don't have the side. I can't figure out the side, but I can figure out the angle. And you have a calculator. If it's a calculator problem, you have access to a calculator, use it so you don't do something weird and have a brain fart and figure out the angle. What would the angle measure be? How do you figure out the angle? 75. Add them together, subtract from 180, right? So now we're going to do sine of 75 over 28. And then you finish that up. we get? X equals 19.397. Y'all agree with that? And then that's feet, and that is our answer. Any questions at all? Maybe it's just really kind of a plug-and-chug type situation here. All right, let's look at number 5. It says a pilot begins a flight traveling 80 miles northwest to avoid the storm. So here he is, starts here 80 miles northwest. He makes a turn, then he returns us to his original location. A diagram of his flight course is shown to the left. Find the total distance of the flight. All right, so we want the total distance of the flight. That means I'm going to have to find these side lengths. Let's call this one X and this one Y. So my total distance that I'm looking for here is going to have to be 80 plus X plus Y. We agree with that? Okay. So let's start by finding X. X is across from 108. So I can do the sine of 108 over X equals, and then that 80 is across from this angle, but I don't know what that angle is, but I can figure it out. What would it be? 57. So I will have the sine of 57 over 80. So then that means that X times the sine of 57 equals 80 times the sine of 108. So X equals 80 times the sine of 108. This board reacts differently. I'm going to change my writing. Over the sine of 57. Okay, but I'm not going to touch the calculator at this point. I don't care what the actual answer is right now, because if I do that, I'm going to get a decimal that I have to round, and then in the end, I'd have to type it back in. And you never, ever, ever type back in a rounded number. So we're just going to pause right there, and we're going to go solve for Y. All right, so for Y, I'm going to say, all right, Y is across from 15. So I have the sine of 15 over Y, and then I'm still going to use the 80 and the 57, so the sine of 57 over 80. So then Y times the sine of 57 equals 80 times the sine of 15. That means that Y equals 80 times the sine of 15 over the sine of 57. Okay. All right. So now I know how to find X and Y. I have the setup there. I know what I actually want. I want the total distance. That is 80 plus X plus Y. This is X and this is Y. So now you put it in the calculator, let the calculator do the whole thing. 80 plus, I would use the fraction button, put in your X, plus, use the fraction button, put in your Y. Do it all at once. You either have to do it all at once, or if you do type it in, you have to store it in the calculator, and it really just depends on which one's easier for whatever you're doing at the time. I think on this one, it's easier just to type it in all at once. .409, and that would be miles, and that is your answer. So the accuracy of your final answer is very important. That's why you have to understand when you're allowed to round and when you're not. Any questions at all? All right, so there's stuff on the back of your notes. You can just put a big X on it. I didn't mean to put that on the back. It's similar to what you'll see tomorrow, but it's not the same, and we're not going to do it all in one day anyway. All right, any questions at all? All righty.